Hi everyone, in this video we are going to have a look at finding the derivative of compound functions. Now in your textbook you will find, let me see now on page, I'm having a look at my textbook now on page 500, it'll talk about elementary functions. And elementary functions are like the fundamental building block of other functions, I suppose. And they talk about algebraic functions like polynomial functions, transcendental functions like logarithm functions, exponential functions, trig functions, and so on. So all of those things sort of make a group of functions called the elementary functions. And now that we've had a look at the derivatives of trig functions, we are at the point where we've covered pretty much all the elementary functions that we could probably hope to do. And that means when we combine trig functions with the rest of the functions, with the product rule, the quotient rule, the chain rule, etc., we put it all together, it means that we can pretty much find the derivative of almost every kind of standard function that we would like to. And that's what we've got here in this video here. You can see in slide 1 there, I've got let f of x equal ln. Remember, that means the natural log base e. I've got ln of 3x squared multiplied by the sine of x on 2. And the instruction is to find the derivative for f dash of x. So let me start off by writing the solution down, as in literally the word solution. And it just feels right to start with the actual problem itself, which I'm just copying down. X on 2. Okay, now it does pay you, I think, to just pause for a second and just break down what you're looking at so that you can know what kind of tools you'll need. So, for example, I've got an ln function here. Okay, do I know what the derivative of ln is? And you should do, it's 1 on x. The derivative of sine is cosine, so that's okay, we can deal with that. There's also this interior function here, or an inside function, 3x squared. That's pretty straightforward. I can find the derivative of that. Same with x on 2. So we're kind of okay in parts. And then we just need to note that ln has an inside function. So we've got this sort of chain rule happening here that we'll need. We've got another chain rule in here because it's not just sine of regular x. It's sine of, it's not that complicated, x on 2, but nevertheless, it's not plain old x. So we need to treat that with a chain rule. And the last thing to note is that we've got ln multiplied by sine. So we've certainly got the product rule requiring to be used here as well. So there's a whole bunch of parts, but each part is fairly little. So we just take it in turn, figuring things out. Now, because we've got the chain rule and the product rule happening at the same time, it can get a bit confusing with the u's and the v's floating about here and there. So if you're comfortable, I would encourage you to start doing the chain rule in your head if you can, or scribbled on a piece of paper off to the side if you have to, as a separate problem, and then just use the u and the v for the product rule for this example. So I'm going to start by, off to the side, writing my two parts. One is ln of 3 of x squared. So I'm going to say u is equal to ln of 3 of x squared, and I'm going to work out the derivative of that. So if u is equal to the ln of 3 of x squared, then u dash is equal to, well, we know the derivative of the inside 3x squared is going to be 6x. Okay, so 3 times 2 is 6, and then subtract 1 from the power, so we get 6 and then x to the power of 1, or 6x. And then we have to multiply that, because of the chain rule, by the derivative of ln with respect to the inside 3x squared. So that would be 1 on 3x squared. Okay, all well and good. Now, x will cancel out the square here. X goes into x squared x times. That leaves me with an x, and 3 goes into x twice. And so we are left with 2 over x. So that's u and u dash. And we'll do something similar with v. So v is equal to the sine of x on 2. So therefore, v dash is equal to the derivative of the inside, x on 2. So just remember that x on 2 actually means half of x. X divided by 2, or half of x, is the same thing. And so the derivative of x on 2 is just going to be a half. And then we're going to multiply that by the derivative of sine with respect to the inside function x on 2. So the derivative of sine is cosine, and so it's a half cosine of x on 2. So we've got our inside, and we've got our outside. And so all we need to do is apply that to the product rule, which I'll do on slide 3, just so it doesn't get too squishy. So therefore, f dash of x is equal to u dash v plus uv dash. Yep. So u dash v is u dash 2 on x multiplied by v sine of x on 2 plus, for the product rule, so plus uv dash. So we've got ln 3x squared multiplied by a half cos of x on 2. That's it. We're kind of done, but let's just tidy up a little bit. So for the left-hand side of the addition sign, we've got denominator of x, and we've got 2 times sine of x on 2. So we've got 2 sine x on 2 all over x, plus on the right-hand side, we've got a half, which is basically a denominator of 2, and then we've got those two functions multiplied together. So we've got ln of 3x squared cos of x on 2 all over 2. And that's pretty much it. We're done. The question might say, find the derivative of f and express as a single fraction, in which case you would have to find a common denominator there by multiplying the left-hand side of the addition sign by 2 and the right-hand side of the addition sign by x. If you had to, there might be other things that it asks you to do as well. But if it just says find the derivative, I don't think there's anything further to be gained by finding a common denominator. So you would leave it like that and you'd be done. This is one of the questions from the textbook. If you find it, and then you look in the back of the textbook, you'll see that it has it in a different order, but effectively all the elements are the same. It's just the order that's being presented slightly differently. I think that'll do for this video. Hope that made sense to you. A hooroo from me.